Hey there, in this video, I'm going to talk about terminal velocity. So before we get started, I just want to let you guys know that terminal velocity, it is basically the velocity. It is not accelerating or decelerating. That simple, which means the velocity, it is constant. And the V right here, it is velocity. And the next one, I want to talk about air resistance. So let's say if a person it is falling from the sky, a free fall, and if the body of the person keep colliding with the air molecules right here, we will have air resistance. If the surface area of the person, it has great surface area, which means it will collide more air molecules, right? So if the collision increases, which means the air resistance increases as well, like this. Collision increases, air resistance or the drag force increases as well, which means this is your weight and this will be your air resistance. Here, short form AR. And one more thing is that if you increase in speed, which means increase in velocity, which means you increase in speed, right? So if you increase in velocity, you will increase in collision as well with air molecules, because if you move faster, you will collide more and more air molecules. This causes increase in air resistance as well. This is the basic concept. So right now I'm going to talk about free fall, okay? So let's say we have an aeroplane here. And the person, and we have a person here jump from the aeroplane, which means the person, it will like this, right? Okay, so this is the person. So first, when this person, let me just call this as person A, okay? When this person A dropped from the aeroplane, it has weights in it. Let's say it has 10 newtons of weight in it. So as this keep falling, this person will collide with air molecules because we will have a lot of air molecules in our air. Okay? So if it collides with air molecule, it will increase in drag force as well. Okay, it will increase in drag force. First, it will start from maybe 0, then slowly 0, maybe 0.5, then slowly 1 Newton, then 2 Newtons, 3, 4, 5, okay? So the drag force, it will slowly increase. So this is our drag force. Like this is our drag force. So as this keeps going, the drag force, it will become 10 newtons as well. 10 newtons. Because every action, there is always an opposite but equal reaction, right? So if the weight of this person, it is 100 newtons, the drag force will be 100 newtons as well. But it takes longer time to reach 100 newtons in this case. So if, let's say this is our positive 10 newtons, the velocity, it is going to be 10 newtons, and this guy, it will be negative. So 10 newtons minus 10 newtons. Let me just use green pen. 10 newtons, it would be 0 newtons. So there is no resultant force in this case, but F equals to ma, so mv minus mu over t, right? Our final and initial velocity, let's say it is going to be 2ms squared in this case. 2ms squared. So there is still velocity in it, but the resultant force, it will be 0, which means this guy, it is still moving, but it has zero resultant force in it. So since we have zero resultant force, which means it is not accelerating or decelerating, then we will call this as terminal velocity. Okay, so no acceleration or deceleration, like this. So let me just erase this first. So let's say this guy reached until certain amount of level. This guy opens up a parachute. In this case, I will put this one. Okay. Opens up parachute. And just now I had mentioned is that if you increase in surface area, you will increase in air collision. If you increase in air collision, which means it will have greater drag force or air resistance drag force. So as you can see in this case, the surface area of this parachute, it has greater surface area, which means it will collide with more and more air molecules like this. Collide. And the weight of this guy, it is constant, which means 10 newtons. It is the weight. So when this parachute opens up, it will have large amount of air resistance. Maybe 30 newtons, maybe even 14 newtons. But all I know is that the air resistance, it is greater than the weight at this moment. In this case, in this moment. So the resultant force, let's say the resultant force, it is going to be 30 newtons in this case. So 30 newtons minus 10 newtons, it is going to be 20 newtons. So when you fall like this, when the moment you open up the air parachute, you experience a drag for a while, then you will fall it back. So in this case, the moment it drags you backwards or drags you upwards, which means you have the resultant force of upwards right here. But as I mentioned also just now, if you increase in velocity, let me just draw a line here. Velocity. Okay. So since you have the resultant force facing upwards, in this case, facing upwards, which means you will decelerate, right? You will decelerate downwards. Or you are decreasing the acceleration, which means in this case, you will become slower. If you have become slower, which means you decrease in speed as well. Velocity and speed, they are almost the same. It's just that it has direction in the velocity, and you will decrease air collision as well. So what happens if you decrease in air collision? You will decrease the drag force or the air resistance. You decrease air resistance or the drag force as well. So this guy, it will slowly become 30 newtons, maybe slowly 25 newtons, then 20 newtons, then slowly to 10 newtons. So until this 10 and 10, we will have no resultant force because 10 newtons minus 10 newtons, it is going to be 0. So we have no resultant force in this case. So yeah, we will have new terminal velocity in this case. We will have new terminal velocity. But what I can say is that the new terminal velocity, it is lesser than the initial terminal velocity. In this case, 10 newtons, we will have one terminal velocity. Okay, so in this case, the terminal velocity, it is greater than the new terminal velocity, because in this case, you will decrease in speed, which means you will have decrease in velocity. So you will still have constant velocity, but it has lesser velocity in it, in this new terminal velocity. So the most important thing in this page is that You have to know what is terminal velocity. You have to know how the surface area affects the collision and how the velocity affects the air resistance. In this case, you just have to know these three things, these basic things in this free fall diagram or this terminal velocity topic. So that's it for this video. I hope you have understood what I had just explained, and I will see you in the next one. Bye.